Thank you for watching this video. So in this video I'll be doing question 5 of May, June 2021 question paper mathematics paper 1. And these are functions. So we have a parabola and a straight line, as you can see here. So I'm going to read the statement and then proceed to answer the questions that follow. Okay. Question 5. Sketched below are graphs of f of x and g of x. So as you can see here, we have the sketched g of x and f of x function. You are told a and b are the x-intercepts of f. You are told that a and b are the x-intercepts of our f here, which is the parabolic function. C is the turning point of f. C is the turning point of f. So I'll just summarize what I just read. So you are given this equation of f and this equation of g here. So you are told that a and b are x-intercepts of our f, the right function, and c is the turning point of f, the right function. So let's go. 5.1. Calculate the coordinates of a and b. So you are asked to calculate the coordinates of a and b. What is a and b? You are told that a and b are the x-intercepts of our function f. So a and b are the x-intercepts of f, right? And you know, if your function, you know, along this line here, this horizontal line, y is 0 there, along the x-axis. So you know that y is equal to 0, which is f of x is 0 along that line. So you want to find the values of x that are corresponding to y being 0. The x values that are sent to y is equal to 0. That's what you're looking for. So you say, okay, f of x equal to 0. What is our f of x? Our f of x is minus 2x squared plus 4x plus 16 is equal to 0, right? Then divide by minus 2, divide by minus 2, divide by minus 2, divide by minus 2. So what do you have? You have x squared minus 2x minus 8 is equal to 0, right? Then you factorize this because we're solving for x now. So you have the two brackets here. You have x, you have x here, right? And the factors is 4 and 2. We have plus 2 and minus 4 here. So if you're not sure about how to factorize, you can always use a quadratic formula from here. Quadratic formula is for someone who's not sure about their factorization. It will always work. So x plus 2 is equal to 0, or x minus 4 is equal to 0. So x is equal to minus 2, or x is equal to 4, right? So the negative 1, x is equal to minus 2, I'll think this is minus 2 here. Let me use that, well, it doesn't matter. This is minus 2, and here I have 4. So the coordinates for A are minus 2 and 0. Coordinates for B are 4 and 0. We're done with this question. Going to 5.2. Determine the coordinates of C, the turning point of F. So now we want the coordinates of C, the turning point of F, right? You know, if C is a turning point, this is an axis of symmetry, right? So this function of ours is symmetrical about this line here. See, the distance here is the same as distance there, right? So if this distance is the same as this distance here. So if you want the axis of symmetry, which is the turning point, the line of symmetry, we can use the midpoint formula for the x coordinates of turning point. You can say, okay, x coordinate turning point will be what? x1 plus x2 all over 2, right? Then this is what we want, the x coordinate of the turning point, xtp. x1 is the x-intercept 1, which is 4, plus x-intercept 2, which is minus 2, all over 2. And this is equal to this and that is 2 over 2, which is equal to what? It's equal to 1. So we get that our x coordinate for the turning point is 1. What do you want now? We want the corresponding y value. Corresponding y value, to get it, you substitute the x coordinate on the original equation, which was this one here. So we want f at 1. F at 1 is equal to, f at 1 is equal to negative 2 into 1 squared plus 4 into 1 plus 16. Punch this in a calculator, then you get your f at 1 to be what? I'm going to use my calculator to punch that and see what my answer will be. So negative 2 into 1 all squared plus 4 into 1 plus 16. Our f at 1 is equal to what? Is 18. So our coordinates for C, the x value is 1 and the y value is what? Is 18. So these are the coordinates for C. So we'll move on to 5.3. This is 5.3. 5.3. Write down the range of f. They want you to write the range of f. So what is the range of a function? The range of a function, I would say, it is a set of y values that are used by a function. It is a set of y values which are used by a function. So if you look at this, the coordinates of C is 1 and 18, right? So if you look at the y values, these are the y values, right? So the y values on which are used by this function are all the y values going downwards, because for each y value you will always find the corresponding x value that will be mapped to this. So for example, this y value here, you see, you'll always find a corresponding x value for it. So even if there are two like this one, even for one down here, you'll always find something, right? You'll always find a corresponding x value for it. And then, but now, the y that is up there above our turning point does not have a corresponding x value, right? So the ones that we want are the ones that have corresponding x values. So if your y value is above here, there's no corresponding x value because it does not hit our graph. So our graph is not defined above our turning point. So we want all the y values that have corresponding x values, right? So if you look at it, you'll find that all the y values from here going down have the corresponding x values. So how do we describe all this interval down here? So what you say your y should be less or equal to 18, or just say y is an element of what? Negative infinity to 18. That is your range. It's a set of y values that have corresponding x values. So all the y values below here will always have corresponding x values as I've demonstrated here. That's how we look for a range. So now we move to 5.4. 5.4 reads as follows. The graph h of x, which is this here, has a maximum value of 15 and x is equal to 2. Determine the values of p and q. Let me try to read this again. The graph h of x, given by this equation here, has the maximum value at 15, maximum value of 15, and x is equal to 2. Determine the values of x and q. So you know, this, if you have a situation like this, where f of x plus whatever. So h of x is defined by shifting horizontally. This part is a horizontal shift, and this part here is a vertical shift. Right? So, this part is a horizontal shift, and this part is a what? Is a vertical shift. So that's telling you that h of x is obtained by shifting f horizontally and vertically, such that the maximum value of our function is 15 and at x is equal to 2. So from the graph that we have here, we have a maximum value of 18 at x is equal to 1. So the maximum value of our function f is 18 at x is equal to 1. So now we're told that now our new function h of x, which is a shifted version of f, horizontally shifted and vertically shifted, have a maximum at 15 at x of 15 at x is equal to 2. So they want us to find p and q. That's what they want us to find. Okay. So the first thing to do, I think this is one of the easiest ways. You can express f of x in the form ax minus p all squared plus q, right? Where your a is your first term, this p is your x coordinate of a turning point, and q is the y coordinate of a turning point. This one is the coefficient of x squared, actually, sorry, not first term. So f of x is equal to a. What is the coefficient of your x squared? Coefficient of x is minus 2. So you have minus 2 here. X minus, this is the x coordinate of the turning point. What is the x coordinate of the turning point? It's 1. So x minus 1 all squared. Plus q. Q is the y coordinate of the turning point plus 18. This is what we have. Right? So now, our function f, h, is obtained by shifting f and shifting f and horizontally and vertically. That's what has been done. That's how they transformed f to produce h. So what we do is say, okay, our h of x, right, is obtained by transforming f. So we're going to apply the transformation they did on f here, right? So we'll say, okay, h of x is equal to negative 2 into x minus 1, and then plus p, that is their horizontal transformation, all squared, plus q. What is their q? Their q is, so now I want to complete f that is transformed. It will be this plus 18. Then you add q. So this part here, this part is f of x, is f of x plus q. Actually, it's f of x, it's just this f of x here. This one is just a horizontally shifted version of f together with that. So this, all of this part is f here, it's this guy here. And then now we apply the vertical shift, right? So what do we do? Say, okay, h of x is equal to minus 2 into x minus 1 plus p all squared plus 18 plus q. So you are told that your maximum, the maximum of this function is 15, which means this part is what? It's 15, this part. And x is equal to 2. So and x is equal to 2, right? So which means what you can do, what you should do when you're here. So okay, this part is this part, which is, sorry, this part, this 15 is this part here. So what you're going to say, okay, my maximum of 15 is equal to my 18 plus q. Then transpose the 18, you get that q is equal to 15 minus 18. Therefore, Q is equal to minus 3. Done that. Then you go to the next part. So you are told that this happens at x equal to what? X is equal to 2. So what do you say? Okay, you say, okay, my 2 is equal to what? Is equal to 1 minus p. Then you transpose your 1, so you have 2 minus 1 is equal to minus p. So you get that your 1 is equal to minus p, which is your p is equal to minus 1. So we have q equal to minus 3 and p is equal to minus 1. Those are the values of p and q. Okay, so now just clean the board. So now we're going to do 5.5. Determine the equation of the inverse of g in the form y is equal to. So they want us to find the inverse of this equation here in the form g, y is equal to something. So what do we do? So when you want an inverse of a function, you reflect about the line y is equal to x, right? So when you reflect about this line y is equal to x, your x and y become what? Y and x, right? So now you have that your g of x is equal to 2x plus 4, right? So now, to apply this transformation, your x and your g of x will become what? G of x and x. So it's more like you're swapping. This goes here and that goes there, right? So what do we have? You have your x sitting there. X is equal to 2 times your g of x, but now your g of x is y, because they say you must write in the form y is equal to y plus 4. So your x and y swap around to apply this transformation here, and then solve for y. What do you say? Say, okay, transpose the 4 to the side, and x minus 4 is equal to 2y. Then divide by 2, divide by 2. Therefore, your y is equal to x minus 4 all over 2. So, we're done with this one. We'll go to 5.6. So, now we're doing 5.6. 5.6 reads as follows. For which values of x will the inverse, the product of the inverse and the original be 0? What are the values of x for which you multiply, when you multiply your inverse and your original is 0? Right? So, in order to get the product of 0 between these two functions, at least one of them should be 0 at that point or at those points. So, if you're multiplying two things, if you're multiplying a and b and the product is 0, it's either a is 0 or b is 0, or both of them are 0. So, if you multiply the inverse and this original and you get the product is 0, then which means at least one of them is 0 at that point. How will you achieve this? So, if you, let's say, if we reflect about this line here, y is equal to x, this is y is equal to x, right? Reflect this about this line y is equal to x, it will move somewhere here. Let me use another color. This reflection, the reflection of this graph will more or less move here, right? And here you will have your minus 2 here, and that you will be 4 there. So your inverse of g will have a shape like this. if you reflect it along that line. Right? So, you will have the product of 0 if one of them is 0. For example, here, your G is 0, but your G inverse is not 0. So at this point, which is x, is equal to minus 2. The product of these two will be 0. Right? So at x is equal to minus 2. The product of the inverse and G will be 0 because the y value of the G is 0 at this point. Where will this happen again? Here. You see the y is 0 here again for the inverse now. Because your G prime at x is equal to 0 here. Here, your G at x is 0. G at x or minus 2 is equal to 0. So, we have a y0 value here as well. But the other one is positive there. But their product, the product of this value here and this value here will be 0. So we'll also observe this at x equal to 4. We're done with 5.6. We move to the next one, 5.7. So 5.7 reads as follows. If p of x is equal to f of x plus k, determine the values of k for which p and j will not intersect. Right? So, you are given a function p of x as f of x plus k. Right? So, I look at this k as a vertical shift of k, of f. So, k is a real number. So, you'll be shifting at verticals either up or down depending on what value of k is. So, they're asking, what are the values of k? What are the values of k? What should the values of k be in order for our new function p and g not to intersect? That's what they are asking. So they're asking, in simple terms, they're asking how many units should we drag g down to form new p, such that our g, so that our p does not intersect g, which is the straight line here. That's what they're asking you. They're asking how many times should we drag f downwards in order the new version of f, which is p of x, not to intersect this graph here. That's what they're asking you. How do you approach this? You can say, okay, my p of x is equal to f of x. What was f of x? F of x was minus 2x squared plus 4x plus 4x, sorry, plus 16. Then it is f of x, then plus k, right? And then we have our g of x. Our g of x is equal to 2x plus 4. So, what they're asking, what should this value k be in order for this equation, this function here, not to meet with this one. So, we want these two things not to meet. Okay, let's suppose that, let's say we want to find out where they meet, right? So, if we find out where they meet, we say, okay, p of x is equal to g of x, right? Which means 2x plus 4 is equal to minus 2x squared plus 4x plus 16 plus k, right? So let's say we transpose these guys to the other side. What do we have? We have 2x squared minus 4x plus 2x, which was there already. minus 16 plus 4, that was there already, right? And then what do we do else? Next, we transpose the k to the other side. So minus k is equal to 0. Let me double check. So this 2 went to the other side, it became 2x. This 4 became negative 4x. Plus that 2 that was already there, right? Minus 16, which is, 16 become negative 16, which is this. K will become negative k, which is that. Then you add the 4 that was there. Then you simplify. 2x squared minus 2x minus 12 minus k, right, is equal to 0. So, if we are saying these two equations should not meet, right, that means this equation should have no solution. It should not have a real solution, this equation. So if we're saying we want these two guys, this J and P not to meet, that means they must have no solution. And in order to obtain a result of no solution here, the gradient, our discriminant should be less than 0. Right? In order to obtain a no solutions, in order for this equation to have no solution, the discriminant of this equation should be less than 0. So, we know our discriminant is b squared minus 4ac should be less than 0. So now we substitute our thing to our formula. So what is our b? Our b is negative 2 squared minus 4a, what is our a? It's 2. And our c is that minus 12 plus k, right? This should be less than 0. What do we do? This is 4 minus this and this plus 8 into 12 plus k. We're solving for k here. So we have what do we have? We have 8 into 12 plus k is less than negative 4. Then divide by 8, divide by 8. So what do we have? We have that 12 plus k less than negative half. So k is less than 0.5 minus 12. So k should be less than 12 and a half, negative 12 and a half. So k is an element of negative infinity to minus 12,5. So k in this interval, or in this range or open interval, will not have a real solution. If our k is this, if our k is anywhere in this interval, then these two equations p and j will not intersect. If our k is less than negative 12 or is in this interval there. So